Electrostatic. Basically, in electricity section, we divide electricity section or like electricity, magnetism combined, right? So we divide whole section into four topics or four chapters. One is electrostatics. Electrostatic is about the study of rest charges. So when charges are still, when charges are not moving, so that part is known as electrostatic. So in this chapter, we will discuss only about the basic of charges, the properties of their charges, and the concept of the transfer of the charges on the surface. The next section will be about electricity, like the moving charges. The third one is about magnetism, like simple magnetism. The final one will be electromagnetism, whole combined section of electromagnetism. So we will divide this electrical section into four topics. So this is the first one. So in electrostatics, in our normal science, we already know about the charges. How many charges are there? You know that there are two charges, right? One is the positive, other is negative. You also know about the name of the charges. Like positive one is called proton, negative one is called electron, right? So you already know about some basic information of the charges. But first of all, if we want to write the definition of charge, so charge can be defined because when someone asks what is charge, so we always used to say like charges are positive and negative. They repel each other when we place like charges close together. They attract each other when we place unlike charges. So we know the concept of the charges, but we never used to write the definition of it. So the proper definition of the charges, it is a physical property of matter. Physical property of matter that causes a body to experience force in an electric field. So basically, for electric field and for magnetic field, both are like invisible to us. We are not able to observe and see that magnetic and electric field in our daily life. So we can like observe those field by their impact on something. For example, if you place anything metallic nearby the magnet, so it attracts towards the magnet. So then we observe, yes, that there is a magnetic field. In the same way, we do the same thing for the charges. So that's why the definition of charge also states the same thing. It is a physical property of a matter that causes a body to experience force in an electric field. So let's suppose if you place positive charge in electric field, so it will attract towards the negative, it will be repelled by the positive. And if we place negative charge in electric field, so negative charge will be attracted by the positive plate, but repelled by the negative. Okay. So this is the simple idea of the charge. Because again, we cannot see directly the field lines. So that's why we cannot exactly identify that how and where the field exists. So we can test by using the test charges. And the other concept we already know, the positive and the negative charge idea. Positive charge, negative charge. Positive charge is called proton. Negative charge is called electron. And there is one more similarity between them. The similarity is both have same values, but they have opposite charges. For
Yeah.
example, yes, we have +1 charge on proton, -1 charge on electron. And when we used to write their final values, their magnitude basically, so that is equals to +1.6 exponent -19 coulombs, then 1.6 -19 coulombs. And this C is the unit of, sorry, the symbol of coulomb. Coulomb is the SI unit of the charge. So the symbol is C and the SI unit of the charge is coulombs. It is on the name of the scientist because we have Coulomb's law in electricity, but we will study that Coulomb's law later, not in O levels and IGCSE. So that's why the SI unit is also called coulombs on the name of the scientist. And you also know that like charges repel. So like charges repel. We are writing all the basic and important information related to the chapter, right? I know that you have knowledge of all these things, but we are writing just to remember that these things are the part of our syllabus, okay? Because if we are not writing, so when you revise, so you got confused what topics are the part of syllabus and what part are not. So unlike charges, attract. So this is the whole basic information related to the charge, and mostly we already know about these things because we studied them in the previous sciences subjects also. Now, the concept of electric field, because in definition we used to mention about electric field. So that electric field is something new idea we are going to discuss in this chapter. We know that electric field or field is like something in which we experience a type of force, like gravitational force, magnetic force, electric force. So there are different types of field also. But right now we are talking about electric field. So first of all, let's define electric field because they used to ask definition of electric field in the exam. So electric field is simply like the concept of the region. A region in space around a charge. So for example, if you place a charge, so in the surrounding of the charge, there is a specific region in which that charge can attract any other charge or it can repel any other charge, right? So a region in space around a charge. When another charge experience electric field.
Sorry, 1 minute. Can you please scroll up?
Repeat this concept of electric field.
No, just scroll up once.
Okay.
Okay, thank you.
So, right. This is the idea of,
So you'll be settling these loads, right?
yes, I will update in the same pattern, in the same link, right? So we already have folders of thermal, journal, and waves. I will update the folder of electricity and magnetism. So you will get all the electricity and magnetism notes in that folder. Plus the previous worksheets are also uploaded. So you can continue from the new questions of the worksheet. So for electric field, it is a region in a space around a charge where another charge experiences electric field. For example, if we place a positive charge, so let's suppose if we place a positive charge, representation of the field lines are also important because in our paper, sometimes they used to ask about to complete the diagram, to draw the diagram of this charge with this field. So diagram is also important for electric field. So first of all, if we consider a positive charge, so in the surrounding of positive charge, we have to draw field lines in this way. So these are the field lines. And in this field line, we have to show this direction also, outward direction. So these outward direction represents that the electric field of the positive charge is radially outward, right? In the same way, if we consider negative charge also, then we will discuss the rest of the property. So for the negative charge, the field lines will be in the same pattern, like we have in upward direction, in downward direction, right, left, diagonal, in all directions basically. In this way. But the difference you observe in the diagram is of the direction. So the direction of the field for negative charge is inward. For positive, it is outward. For negative, it is inward, right? So this is the main difference between positive and negative electric field lines. For positive field lines are always radially outward. And for negative field lines, these negative field lines are always radially inwards. So the first important thing you have to remember for electric field lines is about the correct direction of arrows. So you will get marks for correct direction. If directions are missing, so you will not get this mark for direction. And the second mark you will get for radial field lines. And do you know the meaning of radial field lines? Basically,
I'm not sure.
okay. So radial field lines means we consider a charge as a sphere, right? So for example, if charge is like a tennis ball that is completely spherical, so from tennis ball on the surface of the tennis ball, you can mark unlimited points on it. Okay. So in the same way, field lines can emit from any point of the charge of the sphere. Okay. That is called radial. Radial means you can mark field lines or you can draw line from any point on the sphere. There is no restriction, there is no specific point, or there is no specific direction that from this way the field lines move outward or inward. You can mark a line from any point on the sphere surface. Okay. So that means radial. So that's why we used to mark field lines in all the direction. In all the direction, it means that field line can emit or field line can flow from any direction. Okay. Because sometimes student used to draw field lines only on right hand side, only on the top side, only on the bottom side like this. So that is not correct representation. You have to show field lines in all direction. So that is the meaning of radial field lines. So now let's suppose if you place a positive charge over here. Let's suppose if we place a positive charge at this point. So what will happen with this positive charge? If you place this positive charge in the positive electric field, so what will happen with this
So,
positive charge?
positive will be right.
Yes. So both will, sorry, the positive charge in the center repels the positive charge that is marked with the green color. So this is the direction of the force on the charge, force of repulsion, right?
Oh, okay.
Yes. And for example, if you place this positive charge in the negative field, so then,
Then it will attract.
yes, force of attraction. But for example, if you place this positive charge somewhere like from the outside of the field of positive and the negative charge, so when we place outside uh, the field lines, so there will be no force of attraction, no force of repulsion. Okay,
Yeah.
because it is out of the field, so no force. Right? Any question, any confusion?
No. No.
Okay. So this is the basic idea of the electric field and also the concept of the field lines, how to draw the field lines and what is the concept of the field pattern. Now the next idea we need to consider is about the like and unlike charges placed close to each other, because we know that when we place like charges, so like charges repel each other. So for example, if we place like charges close to each other, so what will be the field pattern? Like this is the question. And what will be the pattern of the field line if we place
Like,
like charges together? So this is the question, and this is the topic we have to discuss next. Any
okay.
question?
So it's
Mhm.
gonna be the same thing like the like charges repel and then the
Yes,
unlike.
yes, but in the concept or in the form of what we say, the diagram form, not in the theoretical form, right? We know the theory that how it repels, how it attracts, but we don't know about the like the pattern of the field lines. So, for example, if we consider the field line pattern for the like charges first. And one more thing you observe, that electric field always flows from positive to negative, because from positive the lines or the field lines are outward, and from the negative field lines are inward. So from this idea we can say field lines are directed from positive to negative charge. So this is the same idea like the magnet. In magnet, uh, field lines flows from north to south, right? But now we have charges. So in charges, it always flows from positive to negative, just like the conventional current. Okay. So this is the idea. The second thing is about field lines for like charges. So for like charges, again, we have to consider two positive charge, let's suppose. Because positive field lines always travels from the positive to the negative side. So that's why we consider the positive one. And when we draw field lines, so we have one positive in the front of the other. So when field lines try to travel in the direction of the other positive charge, so it bends because of repulsion. Same thing happen with the other charge, like this, right? In this same way, you have to draw the curved field pattern this time because of repulsion. So this is the pattern for the field lines. All are moving outward because both have positive charges. So the direction of field lines will be outward. But one more thing that we observe in the diagram, that we have a very large gap between both charges, like this one. This region is completely empty. So why this region is completely empty? You observe that because of repulsion, both field lines repel each other, and because of repulsion, there is a gap between both field lines, right? So because of the field lines, they repel each other, and we got a gap between both charges. So this gap actually represents. They used to ask about this point in exam also. This is called a null point. And why it is called a null point, you can observe from the diagram that there is no field lines. For example, if you place any charge in this specific region, so that charge will not move in any direction because there is no electric field exist at this point. Okay, so no electric field exist. So this is about null point. And if both charges are equal, so definitely this point will be in the middle. And the second concept is about unlike charges. So for unlike charges, definitely we have to consider one positive and one negative charge. So from positive to negative, we know that field lines always travel from positive to negative. But there is one more difference. We have to draw a gap between the field lines. So now in this diagram, there is a simple difference. Field lines always travel from positive to negative, like this. So directions for the field lines are very, very important. So never skip those field lines. Otherwise, you will lose your mark. So in this, unlike charges, this is the pattern. So pattern is very easy because we know that field lines always travels from positive to the negative side. But the question is, there is a gap between the field lines. The gap between the field line means this one. You can observe that there is a gap. If you observe first and second field line, and then you observe second and third, so you can see gap is increased. So this gap needs to be increased in your diagrams. So when you draw the diagrams by yourself, so always remember you have to increase the gap between the field lines, because the gap between the field lines or the increasing gap between the field lines represents that we have weak electric field away from the charge. Okay.
Okay.
So we have now three important points. Before that, we have only two important points: correct direction, radial field lines. But now, if they ask you to draw this diagram, complete this diagram, so there are three important points. The first one is correct direction, definitely. Correct direction means positive to negative. Then, second point, very, very important, gap between field lines increased. So you have to increase the gap between field lines. So that is very, very important because it will give you 1 mark in your diagram. The last, radial field lines. So any confusion, any question at this point? Okay. So basically, uh, these are both diagrams, and in these diagrams, the unlike charges diagram is important. In the sense, we have to remember the gap between the field lines, and the idea of the gap is, for example, if we have less gap, so what happens? And if we have a large gap, so what happens? So these are two questions.
There's a less gap, that means that the force of attraction is more, and then if it's a more bigger gap, then the force of attraction is decreasing and it's becoming less.
Right. So if there is a less gap, so it means field is strong. So when you are close to the charge, so you experience a strong field. But if you are away from the charge, just like the magnet example, when we place magnet close to the conductor, so it attracts quickly with greater force. But when magnet is placed away from the conductor, so it attracts but with less amount of force. So that is called weak field lines. So this is the scenario of the like and unlike charges with their field diagram pattern. So any question in this?
Yeah.
Okay. And before 2023, if we talk about the syllabus update, so before 2023, there are like so many topics in this electrostatic section, right? But after like update of the syllabus in 2023, we have very limited topic in this chapter. So this chapter is now very limited. This chapter is now very simple. So you don't need to study many things in this chapter, and you can complete this chapter easily in your next class with some past paper practice questions also. For example, if we consider some questions related to this field concept that we discussed today, that how we will get questions in our past papers related to the field lines. So in 2023, you can see the same type of the practice worksheet that we use for journal physics and thermal. Right now we have for electrical and magnetism section. Question number 7, it shows the electric field pattern around a point X. So point X in the middle, and there is a point Y. On figure 7.1, draw an arrow to indicate the direction of the force on a negative point charge placed at point Y. So what will be the direction of the force on this negative, this is negative charge.
It attracted towards the
Yes. So you know that we have positive charge in the middle because all field lines are moving away from the center to the outside. It means all field lines are of the field lines of positive charge. So there is a positive charge in the middle, it is confirmed. So positive is in the middle, negative is placed in the field. So there will be force of attraction. It means towards the center, right? So this is the simple concept for 2 marks. Then what is at point X to produce the field pattern? So we have positive charge uh, in the middle at point X. We have positive charge at point X because all field lines are radially outward. B part is a piece of plastic is charged positively by friction. State what charge transfers occurs during this process. Now, this is another topic that we have to study in this chapter, which is about the transfer of the charges, because this chapter is about static charges. So charges are not going to move like the charges moved in the wires, because that chapter is for electricity. Right now, we are only talking about rest and still charges, so they are not moving, they are not traveling in our questions. You observe that we only discuss about the idea of field pattern. So there is no concept like the moving of the charges right now. And in the same way, if you search for the concept of electric field in your past papers, so this is another question. Ignore the first part because that is about the transfer of charges on the surface only. So, but from B part, figure 7.1 shows a negatively charged metal sphere S. There is an electric field surrounding S. So what is meant by electric field? So the definition of electric field, you
a
have
region in space where the charge is around another charge and it experiences a electric field.
electric field, right? So you need to copy paste this definition for 1 mark. Then on figure 7.1, Draw the pattern of electric field surrounding sphere S and indicates its direction. So you need to draw the pattern of the electric field surrounding sphere S and indicates its direction. So this is negative charge given, right? So on negative charge, now this is the question, you have to draw the diagram by yourself, like in this pattern. You have to draw from all the direction to show the concept of radial lines. Otherwise, you will not get full marks if you only mark from one side. So try to mark from different direction. And sometimes in question it is mentioned that at least three, at least four, just like in this question, no number of field lines is mentioned. So it's your choice. But in some questions, it is mentioned that you have to draw at least four field lines, at least three field lines. So then you can draw limited one. Otherwise, you have your choice. So for negative, we have inside. So one mark you will get for radial lines and the other mark you will get for these direction of the field lines, that is inward. Figure 7.2 shows a small negative charge Z placed near to sphere S. Charge Z experiences a force due to electric field surrounding S. Draw an arrow to show the direction of this force on Z. So draw an arrow to show the direction of this charge on Z. So Z is also negative charge. So definitely this sphere S repels the negative charge Z. Okay. So this will repel, it will move in away direction from the sphere S, right? In the same way, you will get basic questions from this section also. You can see again we have the same negative charge sphere given. And now it is mentioned, draw four lines to show the electric field and its direction. So now you have to draw four field lines. They are talking about magnetic field, but in B part, they are talking about electric field. This is negatively charged sphere. So you have to draw at least four. So for at least four, we have to draw like two on the vertical direction, and we can draw two in horizontal direction in this way. So this is the concept of the negative electric field lines. Draw four lines to show the electric field. Okay. So this is the concept of electric field lines and electric field concept.